All right, Module 19, graphing quadratic functions. So far we've graphed linear functions, we've graphed absolute value functions, we've graphed exponential functions, and all of those look different. If you graph a linear function, you're going to have a diagonal line that looks like that. If you graph an absolute value function, if you remember from that unit, we have that V-shaped graph. If we graph an exponential, we have that graph if it's an exponential growth. And today we're going to talk about quadratics. And quadratics form what we call a parabola. You might have heard me say that word a few times in class, but parabolas are a U-shaped graph that look like that. Okay, that's what we're graphing today. But before we graph it, let's take a look at some of the parent functions of things that we've already graphed in this class. So we've already graphed basic linear functions, and that's this right here, okay? And the parent function of a basic linear function is just going to be y equals x. Domain is all real numbers, and range is usually all real numbers, okay? And that's just a basic linear function. We've also graphed absolute value functions. The parent function of an absolute value function, and you should recall this from that unit, is y equals the absolute value of x. Domain is all real numbers, and your range is just going to depend on where your vertex is. In the parent function's case, it's going to be y is greater than or equal to 0 because our vertex was 0, 0, and all of the y values are above that vertex, and that's why we have the greater than or equal to. Okay, and we also have constants. So remember, if we have y equals a number, we have that horizontal line, and converse of that, if we have x equals a number, then it's going to be that vertical line. But now we're going to focus on quadratics. And the parent function of a quadratic function is y equals x squared. If you have your graphing calculators at home, I encourage you to go ahead and graph that so you can take a look at how it looks. It gives you this U-shaped graph that we call a parabola. Okay, and that's what we're going to be talking about today, this U-shaped graph that we call a parabola. Now, domain is still going to be all real numbers. And your range is going to be similar to our range in when we were doing absolute value functions, where we're going to need to look at our vertex. Okay, so whatever our vertex is, if the graph's above it, then it's going to be greater than or equal to. If the graph's below it, then it's going to be less than or equal to. So it's very similar to what we did with absolute value functions. All right, standard form. The standard form of a quadratic equation is y equals ax squared plus bx plus c. So make sure you write this down. This is very important, standard form. We're going to learn the standard form and the vertex form of quadratic equations in this unit, but today we're just going to focus on standard form. Now, if a quadratic equation is in standard form, then we'd immediately have our y-intercept. Your y-intercept is going to be the c value, and you could write that down, c equals the y-intercept. This is if it's in standard form. And A and B are going to be values that are going to help us find what we call our axis of symmetry, which I'm going to explain what that is in just a moment. And they'll also, because they help us find the axis of symmetry, they'll eventually help us find the vertex as well, which vertex is a word that you should be familiar with already. When we were dealing with absolute value functions, vertex was the turning point of that absolute value V, that absolute value graph. Same thing here. Vertex is going to be the turning point of our parabola. Now, you don't have your graphing calculators, but we're going to do this tomorrow. But what I really wanted you to notice with this is these two quadratic equations are in standard form. If we look at the A position on both of them, remember quadratic form, standard form is y equals ax squared plus bx plus c. If we look at the A on both of these, okay, one of them has a positive 1 in the A spot, the other one has a negative 1. So when you graph these, you're going to notice that when you put this in your graphing calculator, you're going to get a U that points upward. And when you graph this one in your graphing calculator, you're going to notice that you get a U that points downward. Okay, so when A is positive, you're always going to get that U that's going to point upwards. Whereas when A is negative, you're going to get the U that points downward. And I'm saying U, but it's a parabola. This is a parabola. Parabola is going to be opening up if A is positive, opening down if A is negative, and we're going to write that down in just a moment. So if A is positive, the parabola opens up like a smile. If A is negative, the parabola opens down like a frown. Okay, so y equals 2x squared plus 5x minus 3. Okay, A here is positive, so we know that this parabola is going to open up. Y equals negative 5x squared plus 4. Okay, no B here, but we do have an A. A is negative. Okay, so we know that it's going to be opening downward like a frown. Now, let's get to axis of symmetry. Axis of symmetry is something that you should also be familiar with from our absolute value section, but the axis of symmetry is an imaginary line that cuts your parabola in half. It acts kind of like a mirror. It splits it in half, okay? And that's called the axis of symmetry. Now, the axis of symmetry is a vertical line. Therefore, this value here is going to be x equals a number, some number. Because remember, when we have x equals a number, we get that vertical line. Okay? And that number is going to be the x value of your vertex as well. Because if you notice, that point there is where our parabola starts to turn going the other direction. Okay, so this x value is not only going to give us our axis of symmetry, but it's also going to give us the x value of our vertex, which in turn is going to help us find our y value of our vertex, and I'll show you how to do that in just a moment. Now, this is how you find the axis of symmetry, this formula right here. So if an equation is in standard form, which is y equals ax squared plus bx plus c, the way you would find your vertex is by plugging the b value here for our numerator, but remember we have that negative on the outside, and then dividing it by 2 times whatever the a value is. So write this down. This is how you find the axis of symmetry of a quadratic equation that's in standard form. And this is how you find the x value of your vertex of a quadratic equation that is in standard form as well. So if we look at this axis of symmetry, remember this is also our vertex, and the main reason why I have this picture here is to show you that the axis of symmetry is your x value of your vertex. Okay, so in order to find the y value, what would you need to do? Just plug in whatever your axis of symmetry is back to your original quadratic equation. That would give you the y value of your vertex. Okay, and I know that sounds complicated now, but we're going to do a few examples and many more examples in class, so hopefully you'll get it eventually. Now, some more vocab. When we're looking at parabolas, if we have a parabola that opens up, then our vertex here is going to be a minimum because it's the lowest point. Okay, whereas if we have a parabola that is going down, our vertex is going to be called a maximum because it's the highest point. So when the vertex is the highest point, we call that a maximum. When the vertex is the lowest point, we call that a minimum. So pause this slide and make sure you write that down. It's very important that you know when your vertex is going to be a minimum and when your vertex is going to be a maximum. Now, let's actually start finding the axis of symmetry and vertex and even sketching the parabola. We're not actually going to graph the parabola just yet. We're going to do that in a couple of slides, but we're just going to do a quick sketch of it. All right, so here we have a quadratic equation in standard form. Standard form is y equals ax squared plus bx plus c. Okay, so if we break this down, what number is in the a position? Well, if we look at this, we have a 3 in the a position. If we break this down, what number is in the b position? We have a negative 12 in the b position. And what number is in the c position? We have a 5. So we know that this particular parabola is going across the y-axis at 5 because remember, c is going to be your y-intercept. Now, they're asking for the axis of symmetry. So you need the axis of symmetry formula, which is x equals negative b over 2a. That's the axis of symmetry formula. So all you need to do is plug things in. Well, b is negative 12. So x is going to equal, we have a negative out here, and let me highlight this, because that negative is not part of the negative 12. It's in addition to the negative 12. So it's going to be negative and then our b So it's going to be negative, and then our b, which is negative 12, all divided by 2 times the a value, which is 3. Well, these two negatives are going to cancel out and form a positive 12. And then 2 times 3 is going to be 6. So what is your axis of symmetry? Your axis of symmetry is going to be 2. And that right there gives us the x value of our vertex. So here we go. How do we find the y value of our vertex? Well, if this is the x value of our vertex, and we're looking for the y value of our vertex, all you need to do is go back to your original quadratic equation, and anywhere you see an x, plug in a 2. So this is going to be y equals 3 times 2 squared minus 12 times 2 plus 5. And you can just put all this in your calculator if you want. 3 times 2 squared. Well, 2 squared is 4, and 3 times 4 is 12. Minus 12 times 2, which is 24, plus 5. Well, 12 minus 24 is negative 12. Okay? And negative 12 plus 5 is negative 7. Okay? So your y value of your vertex is going to be negative 7. And now we have our full vertex. We know the x value of the vertex is going to be 2, and the y value of the vertex is going to be negative 7. So let's go ahead and write some of this out. It asks for the axis of symmetry. We figured that out. The axis of symmetry is going to be x equals 2. It asks for our vertex. We figured that out. Our vertex is going to be 2, comma, negative 7. All right, now it's asking for a sketch. So we know our vertex is going to be 2, negative 7. So I'm going to put this point here, and I'm just going to label it 2, negative 7. And it's a quick sketch. So the other thing I'm really looking for when I'm asking you to sketch this is what if you know whether it's going to open up or down. Now, A is positive. A is a positive 3. So remember, if A is positive, it opens up like a smile. So we're going to have this parabola opening up like a smile. Now, it's probably going to be a bit narrower than that, and we're going to graph that in just a moment, but I'm not expecting you to know that yet. I'm just expecting you to know that it's opening up like that. And we also know that running right down the middle here is our axis of symmetry, which is x equals positive 2. And that's what I'm expecting when I'm asking you to actually sketch these. Now, quickly, how do we graph quadratic equations? We find the axis of symmetry. Quadratic equations in standard form, I should add. We find the axis of symmetry, find the vertex, put the vertex in the middle of your table, and then fill in the table values using a calculator. And then plot the points and connect them into a smooth parabola. Pause the video, write these steps down. We're going to do one example where we graph these. All right, so here we are asked to graph this quadratic equation. So first we would need to find the axis of symmetry, and to do that we would need the axis of symmetry formula, which is x equals negative b over 2a. Now if we look at this, I'm going to break it down. What number is in the a position? Negative 2. That right there tells me that this parabola is going to be opening down. What number is in the b position? 4. And what number is in the c position? 1, which tells me that the y-intercept is going to be 1. So if we're using our axis of symmetry formula, it's going to be x equals negative b, so it's going to be negative, and then b is 4, divided by 2 times number that's in the a position, which is negative 2. So it's going to be negative 4 over negative 4, which is positive 1. Now to find our vertex, we take that positive 1 and we plug it in to our original quadratic. So it's going to be y equals negative 2 times 1 squared plus 4 times 1 plus 1. Okay, 1 squared is 1, and negative 2 times 1 is 1. And then 4 times 1 is 1, and then that's plus 1. So that would give us our answer, which is 3. So let's fill out some of this information. We know our vertex is going to be x equals 1. I'm sorry, we know our axis of symmetry is going to be x equals 1. We know our vertex is going to be 1, comma 3. Our domain is always all reals. Our range, I'll talk about that in just a moment. Now it said put this value, the vertex value, in the middle of your table. And then what you're going to do is you're just going to get some more values. So what I usually do is I just usually count up and down. So from 1, I go to 0 and negative 1. And then above 1, I go to 2 and 3. Okay, so that's what I usually do, just count up or down. And then put all of these values in your calculator. What do I mean by that? So you see this -1 here? Plug that in for x using your calculator and see what y you get. You see this 0 here? Plug that into x, put in your calculator and see what y you get. Same with the 2 and 3. So I'm going to go ahead and do that and fill in the table. I'll pause it and do that. You could go ahead and do it as well in your calculator and see what values you get. All right, and these are the values I got. So now we're just going to plot it. -1, -5 is going to be right here. 0, 1 is going to be right here. 1, 3 is going to be right here. And that's your vertex, so you're going to see it's going to turn now. 2, 1 is going to be right here. And then 3, -5 is going to be right here. And then you go ahead and connect this with that U-shaped parabola right there. Okay, and that's how your parabola looks. It's opening down. So therefore, when we're doing our range, it's going to be y is less than or equal to. And it's going to be less than or equal to what? Well, what is the y value of your vertex here? That's going to be y is less than or equal to 3, because all of the y values are below 3. Okay, so that's why it's going to be y is less than or equal to 3. So I know it was quite a lengthy video, and I know it was a lot of new material, but we're going to spend all day tomorrow on this, so don't worry. We'll get this. All right. Make sure you have all these notes. Make sure you all have these graphs in your notes and all the vocabulary terms in your notes as well. Have a great day. See you tomorrow.